Hello, my name is Kaden BenDebba, and this is my video submission for the TinkerCad simulation for my robot, the base station, as it pertains to my group's fleet of sophisticated window cleaning robots. Before I begin with the code and the simulation here, I wanted to go over some key components of my robot and how they pertain to the objects in this circuit. This is a 3D model of the base station machine. It operates autonomously with the assistance of an operator. Just to give a brief description of how it works, an operator connects a water supply to the left side here. That is the triple reverse osmosis filter. The water is then filtered and fed into this tank on the left side here with the compression box attached. That is the clean water dispensary tank. The robot then attaches to the valve on top. When it is done and needs to dispense dirty water, it attaches to the valve on top of the right tank. And then when the robots are in need of charge, there is a solar-powered charging station attached to the right end of the machine here. This is an image of the compression system attached to the clean water reservoir tank. It serves two main functions, the first of which being the red light to indicate the water level detected within the tank to notify the operator to feed more water into the tank if the levels are not sufficient. It also serves the purpose of propelling the water upward into the robot when the robot is connected to the dispensary valve on top. This is an image of the dispenser valve on top of the clean water reservoir. The robot will attach to this when it is in need of refilling. The blue ring there sort of acts as a pressure plate, which then activates the compression system previously mentioned to shoot the water into the robot, filling it up and getting it ready to clean some windows. Finally, this is an image of the solar-powered charging station for the robots. Functionally, it operates very similarly to the valve in that the ports here operate as pressure plates. When the robots do attach to them to charge, it indicates the machine to turn those on and charge the robots. With that information in mind for the sake of our simulation, the components here represent the pieces mentioned previously, the ultrasonic sensor being the water level detector within the clean water reservoir, the LED up top representing the light that shines on the compression system, notifying the operator that the tank is full and ready for refill. The push button represents the pressure plate, the dispenser valve that the robot connects to. Once that is pushed, the DC motor, which in this case represents the compression system, is activated, shooting water into the robot and refilling it. Additionally, the push button mechanism and its functionality with the DC motor also serves to simulate and represent the charging station once the robot is connected, activating the battery to charge the robot. Finally, moving into our simulation here, the operator has connected the base station to a water supply. It is filtering and it is entering the tank. As the distance shortens, the water level closes into the sensor. Once the sensor detects the water level is sufficient, the red light on top shines, indicating that the compression system is ready for operation and the robot is ready for refilling. Our robot connects to the dispensary valve, the button is pushed, and the DC motor is activated, propelling water into the robot. And that concludes the simulation for my base station robot. I hope you enjoyed watching. Thank you for your time.